talk about covalent compound. You guys know what a covalent compound is? Yes? Yes. Hopefully what you're telling me is that covalent compound is when we have two non-metal. Always go back to the basics. Now, here's a problem. If you remember, we said that covalent compound, two non-metals together. Non-metals want to gain. You have a guy who wants to gain. You have a guy who wants to gain. Two atoms, they both want to gain. So what's going to happen? What they end up doing, they end up sharing. So they end up sharing electron. Okay? Now, if you remember ionic compound was different. Ionic compound, the metal would lose, the non-metal would gain. Because ionic compound was when you had a metal and you had a non-metal. One of them wanted to lose and the other one wanted to gain. It was great. It was a balance of charges. Now, for example, NaCl was an ionic compound, right? How would you draw NaCl? If you had to draw ionic compound, how would you draw it? I would probably say Na is +1 because it lost an electron and Cl is -1 because it gained an electron, right? Now, let's say calcium chloride, a metal and a non-metal again, or ionic compound. How would I draw this? How would I draw calcium chloride? What I would do, I would probably put calcium is +2, and then it would have 2 Cl minuses around it. So is it, again, balance of charges, right? Attraction of charges. That's a better way of saying that. Is an attraction of charges for ionic compound. Now, it's easy to draw them. You just draw the charges and then there's the attraction of charges. Now, how would you draw a covalent compound? So it's easy to draw ionic compound, but how would you draw a covalent compound? So that's what we're going to go over. To draw a covalent compound, and that's going to be our lecture this week. The way to draw a covalent compound, what you have to do, you have to draw a Lewis structure. Because they're harder to draw because it's not balance of charges, it's not attraction of charges. We have to show them sharing electron. So we're going to talk about covalent compound and how we can draw and show they're sharing electron. Now, the first one I'm going to do, I'm going to, let's say, I have H2, okay? H2. Now, one thing I want you to remember, and we talked about this before, how many valence electron does hydrogen have? Hydrogen has how many valence electron? Hydrogen have 1 valence electron. If you guys remember that, we said valence electron or outermost electron. They're far away from the nucleus. Basically, they're the electrons on the last shell, on the last floor. They're far away from the nucleus, so they don't feel the nucleus plus charge. And because of that, they can play around. And hydrogen has 1 valence electron. So go back to the valence electron lecture. You go based on the group. Group 1A has 1 valence electron. Group 2A has 2 valence electron. Group 3A has 3 valence electron, and so forth. Okay, so hydrogen has 1 valence electron. So if I wanted to draw the hydrogen atom out, what I would do, this is a hydrogen, and it has 1 valence electron. Here is a hydrogen, and it has 1 valence electron. Okay, so I have 1 hydrogen atom with 1 valence electron, and I have another hydrogen atom with 1 valence electron. Again, valence electrons are far away from the nucleus. They can play around. So in bonding, we always talk about valence electron. Now, what's going to happen is these 2 hydrogen are going to share these valence electrons. So they're going to share these valence electrons. And if they share these valence electrons, what's going to happen is I'm going to redraw this. So then here is the 2 hydrogen sharing the valence electron. Okay. These are the electrons that are being shared. Now, if I would draw this out, it would be H bonded to H. So this one over here, it has 2 electrons that are being shared. So this is a covalent bond. This is a covalent bond. And a covalent bond has 2 electrons in each bond. It has 2 electrons in each bond being shared. It has 2 electrons in each bond that is being shared. Okay. Now, you might ask me, well, hold on, hydrogen is H2 a covalent compound? It is. When you're talking about covalent and ionic, what I want you to do, I want you to consider hydrogen a non-metal. Okay, so H2, consider H2 a covalent compound. I want you to consider hydrogen a non-metal when we're talking about covalent and ionic compound. So far so good. So consider hydrogen a non-metal. Alright, so again, you can see there's sharing electron, and in a shared electron you have a covalent bond. In each covalent bond, 2 electrons are being shared. Now, let's do another one. Let's do F2. Let's do F2. Okay. Now, I want you to look at the periodic table and tell me how many valence electrons does fluorine have. Fluorine is in group 7A. It has 7 valence electrons. Again, go back to the valence electron lecture. So it has 7 valence electron. And one more time, again, valence electron, what they are the outermost electron. They're the outermost electron, and because they are the outermost electron, they are available. They're available. They're far away from the nucleus. They don't feel the nucleus, plus they can play around. Okay? Now, let's come over here. So I have F2, 2 nonmetals together. Now, I said that each fluorine has how many valence electron? Has 7. So 1, 2, 3, 4, 5, 6, 7. I want to have another fluorine. 1, 2, 3, 4, 5, 6, 7. So far so good. Okay. So again, what I did here, I have 2 fluorine atom, and each fluorine atom has 7 valence electron. Now what's going to happen? What's going to happen is they're going to share electron. They're going to share electron. Okay? They're going to share electron. When they share electron, I'm going to show that sharing right now. So then I'm going to have... my circles, they suck. So they are sharing electron. They are sharing the electron. Sorry, my circles are a little bit questionable. Okay, they're sharing electron. Now, where is the electron that is being shared? The electron that is being shared is right here, right? So they are sharing electron. They're sharing electron. So if I had to draw this out, how I would draw it is I would say F bonded to F. Okay. Now 2 electrons are being shared. Do you agree? 2 electrons are being shared. So here is my covalent bond. Here's my covalent bond. And again, how many electrons are being shared in a covalent bond? Remember, these are the 2 electrons that are being shared. I can even write those electrons out here. Okay, so covalent bond has 2 electrons that are being shared. The covalent bond has 2 electrons that are being shared. We're good so far? Let me repeat it one more time. Even though I know you guys are good. So F2 is a covalent compound, 2 nonmetals together. What that means, they are going to share electron. Each fluorine has 7 valence electron. Okay? Now I have 2 fluorine. What they're going to do, they are going to share electron. Each one is going to contribute 1, and they're going to share electrons. And this is a covalent bond, and each covalent bond has 2 electrons that are being shared. Okay, now the other things to consider what I want to do, tell me how many electrons are around each fluorine right now. How many electrons are around each fluorine right now? Let's count together. This fluorine right now has 1, 2, 3, 4, 5, 6, 7, 8. This fluorine over here has 1, 2, 3, 4, 5, 6, 7, 8. Or if I go over here, that's better because there's a circle. 1, 2, 3, 4, 5, 6, 7, 8. Now this fluorine, 1, 2, 3, 4, 5, 6, 7, 8. So each one, after sharing, they have 8 valence electrons, okay? So after sharing, I'm going to write this down. So after sharing their electron, what's going to happen? What do they have? After sharing their electron, they have 8 valence electron now. You guys are good for before. So before, each one had 7 valence electron. After they shared, now each one has 8 valence electron. Now, why is that important? We talked about it. The same lecture as valence electron, I think. We talked about it. Why is so significant to have 8 valence electron? Because who has 8 valence electron? Noble gases, right? So when they have 8 valence electron, they look like a noble gas. We talked about this before, that noble gases are considered very sexy and good looking on a periodic table. So everyone wants to look like it. So after they share electron, each one ends up having 8 electrons, 8 valence electron. Each one ends up having 8 valence electron, and that's important because now that's going to have 8 valence electron. They're going to look like a noble gas. So what does sharing do? Sharing is going to cause them to be more stable. So they're going to share. When you do, sharing is going to make them to be more stable, and that is why they do it. That's why they want to form compounds. That's why they want to form covalent compounds, because they are going to share, and when they share, they end up with 8 valence electron. Again, each one had only 7 valence electron. They shared. After they shared, now each one has 8 valence electron. Okay, yeah, 8 valence electron. You look like a noble gas. You are good. You are good. Okay, now I want to quickly put up a periodic table. This is to remind you that for valence electron, this has 1 valence. I don't know why I put plus. This one has 1 valence electron. This column has 2 valence electron. 3, 4, 5, 6, 7, and 8. So the noble gases over here, they have 8 valence electron. So everyone wants to look like them. So everyone wants to achieve 8 valence electron. Okay. So these are if you forget them, this is how you would know number of valence electron. That's what fluorine has 7, but after it's shared, it would gain 1 more, and it would have 8 valence electron. Now, one thing to talk about is Octet Rule. Let's talk about Octet Rule. And you already know this. You just didn't know the name for it. Octet Rule is basically you transfer or share electron to form compounds. You transfer or share electrons to form compounds to give atoms a stable electron configuration. And what is a stable electron configuration? We just talked about it. A stable electron configuration is when you have 8 valence electron, because noble gases are stable. 8 valence electron. And again, don't forget that noble gases, what they have 8 valence electron. So what am I saying is that atoms, they form compound. They transfer like ionic compound, or they share like covalent compound. They form compounds by transferring or sharing electron, so they would have a more stable electron configuration. And a more stable electron configuration is when you have 8 valence electron. And you saw it over here that the Fs, they form a covalent compound, they shared an electron, so each one would have 8 valence electron, and to be more stable. And we call that Octet Rule, right? Octa is 8, Octet Rule. Everyone wants to get to 8. So far so good. Okay, let's put up one more table, and then we're ready to do Lewis structure. So the table I'm going to put up, make sure you have half a page. If you don't have half a page, go to a new page. I'm going to write down valence electron and then number of bonds. Okay, have your periodic table in front of you. Carbon, nitrogen, oxygen, fluorine, hydrogen, and boron. You ready? We're going to fill this out together. Look at the periodic table. Tell me, how many valence electrons does carbon have? Carbon is over here. Carbon has 4 valence electrons. Carbon is over here. Carbon has 4 valence electrons. Okay. Now remember, we said everyone wants to have 8. So carbon has 4 valence electrons. How many more valence electrons does it need to be 8? It needs 4 more. That means it would form 4 bonds. Because each bond that you share, you're going to gain 1 more electron. So it has 4. It needs 4 more to have 8. Now that means I'm going to form 4 bonds. Because each bond is going to give you an additional electron. So far so good. Nitrogen. Look at the periodic table. How many valence electron? 5. Okay. Now how many more does it need to be 8? 3. That means it would form 3 bonds. That means it would form 3 bonds and it would end up having 8 valence electron. Okay. Oxygen. How many valence electron? Look at the periodic table. Oxygen has, right here, oxygen has 6. Oxygen has 6 valence electron. How many bonds would it make? It would make 2 bonds. So it would end up having 8 valence electrons. So you have 6 valence electron. Again, each bond gives you another one. So you form 2 bonds. Ends up being 8 valence electron. How about fluorine? Fluorine has 7 valence electron. It is 1 more. So it makes 1 more bond to be 8 valence electron. Alright, now let's go to hydrogen atom. So far so good? Okay. Hydrogen atom has 1 valence electron. How many bonds do you think it makes? Do you think it would make 7 bonds? No, it can't. It only has 1 electron, right? So hydrogen is an exception. Hydrogen makes only 1 bond. And hydrogen is happy with only 2 valence electron. So it has 1, it makes a bond, so it has 2 total valence electron, and hydrogen is happy with that. Okay. Now, let's look at boron. How many valence electron does boron have? When you look at the periodic table, boron has 3, okay? Now, how many bonds does it need? You're probably going to say 5. And you would be right, but you know chemistry, there's always exception. This is another exception. For some reason, boron is happy with 3 bonds and is stable with 6 valence electrons. I mean, we do know why, but we're not going to get into it in this class. So, hydrogen and boron, these two are exception. Everyone wants to have 8 valence electron. These 2 guys are not very greedy. Hydrogen is happy with total 2 valence electron and boron is happy with 6 valence electron. So these are exception to the octet. Everyone wants to have to the octet rule. Everyone wants to have 8 valence electron, but boron is okay with 6. Hydrogen is okay with 2. So far, so good. Okay. There is one more exception. There is one more exception to the octet rule that I want to go over right now to get it out of the way. There's only one more. Here is, I'm going to write down the exception and I'm going to go over it with you. 3rd row down can have expanded octet. 3rd row down can have expanded octet. Now what's going on here? Here's what's going on. Remember we had the nucleus, yeah? And then we had the energy levels around it. And if you remember, the first energy level had only s orbital. The second one had s and p. The third one has sp and d, yeah? Okay, and if you remember, if you're on the first energy level s orbital, the maximum number of electrons you can have is only 2 electrons. If you're on a second level, the maximum number of electrons you can have is 8, right? Because s could have 2, p could have 6, 8 is a max. Now, if you go to the next one, is 2, 6, and then 10, so the maximum you can have is 18. So what you have over here, you have all these empty d orbitals. What does that mean? That means you have room. You have room, okay? Now, I want to repeat this again to make sure everyone is on the same page. Here is the deal. Everyone wants to have 8 valence electron. So everyone wants to have 8 valence electron. But if you end up having more, if you end up having more than 8, that is okay. As long as you're not on a first or second row. Is okay as long as not on the first or second row of the periodic table. So it's okay to be happy as long as you're not on the first or second row of the periodic table. And why is that? On the first and second energy level, the max you can have is 8, right? I don't have any more room to put the electrons if I end up having more than 8 electrons. Okay, so let's go back to a periodic table that I had over here. So the first row and the second row, they could never have more than 8 valence electron because there is no room. On the second energy level, the most electron you can have is only 8. So first and the second row, there is no way you can go have more than 8 valence electron. But starting from the third row down, after this, all these rows, yes, you could end up having more than 8 electrons. So it's from the third row down, okay? So third row and the rest of them, yes, you can have expanded octet. Okay, let's repeat it one more time. So, covalent compound, we're talking about non-metals, right? First and second row, these guys can never have more than 8. Remember, everyone wants 8. But sometimes, if you end up having more than 8 electrons, it's okay. It's okay to be extra happy. But you cannot be on a first or second row. These guys could never have more than 8. So far, so good? Okay, so let's summarize this one more time. Everyone wants to have 8 valence electrons so they can be stable and look like a noble gas. 2 exceptions. Hydrogen wants 2. Boron wants 6. The other exception is everyone wants 8, but once in a while it's okay to have more than 8. It's okay to be extra happy as long as you're not on a first or second row of the periodic table. Okay, so far so good. All right, so we got the groundwork going. We've gone over all the name or all the definition and explanation for bonding. Now, next time what we're going to do, we're going to start drawing the loose structures out. All right, I will talk to you guys next time.